Hi, today we're going to talk about integration, understanding what integration is and how to apply them. So let's get started. So integration is a reverse process of differentiation. So let's say differentiation is multiplication and integration is the division. They are just opposite of each other. So have a look. Given that a function y is equal to 3x squared minus 6x plus 5, if we differentiate this number, we got dy dx equal to 6x minus 6. So just now we say integration is the reverse process of it. If we integrate this one, we will get back the same equation like 3x squared minus 6x plus 5. But slightly change is the 5 become the c constant. The reason it becomes c is because that when we integrate the dy dx, we don't know what the number is for the constant. It can be 6, it can be 50, both are correct. It can be 100, it can be 1000, it can be any number. So we don't know what number, so we put a c. So that is the integration. It's the reverse process of differentiation. So this method is called the direct method because it is directly integrate. Next, we're going to talk about another method. Is by separating the variables. Given that the dy dx equal to 2x over y plus 1. In this case, x and y at the same place. It's difficult to solve two unknowns together. So in order to solve it, we rearrange them, y into dy, x into dx, and we integrate both sides. And we got this answer. So next step is by substitution. Given that this example is difficult to integrate directly because it has a power of 3. So in order to solve it, we substitute the thing inside the bracket 3x plus 5 as u, and then let u equal to 3x plus 5. Since we integrate in terms of u, therefore the dx needs to change to du. How to get du? We differentiate this equation u equal to 3x plus 5. So, and we got 3. We rearrange it, dx equal to 3, du over 3. Then we use this one to substitute here. It's du over 3. And we got this. And then we separate it back and we integrate it. We got u power 4 divided by 4. And right now we have in terms of u, we just substitute the u back as 3x plus 5. And we got the final answer here. So we can solve the exact same question using another method. Let's see. It's the method number 4. Is divide dy dx. If you solve this problem through, let's say this is we're gonna differentiate this one. Surely it's gonna be differentiate this one and times the dy dx of the bracket. But right now it's integration. So we change multiply to divide. So let's see how. We integrate directly, just as normal. So it's power 4 over 4. We treat this bracket as one unknown. So next we're going to divide by the dy dx. The dy dx of 3x plus 5. After differentiate 3x plus 5 is 3, so it's divided by 3. So we got the same answer, divided by 12. And we got at a constant c. Okay, next, after we're learning all the concept, so let's us apply how integration works in some of the real cases. So we understand that the gradient m is equal to dy dx is because of the change of y over the change of x. Okay, so since in max is y2 minus y1 over x2 minus x1, so it's a change of y over the change of x. So given the gradient, we need to find the equation y. So we understand gradient is dy dx. In order to find the equation, we're going to integrate. Given that m is equal to 3x plus 2, so to find the y, we integrate this gradient and we got this equation. So after this is not yet complete, we still have the c. So in order to solve the c constant, another extra information is needed, so which is a point. So normally the question will ask, find equation that this line or this curve will pass through the point. So it's given a point. This is the x-axis for 3, y-axis for 2. So we substitute 3 and 2 into y and x respectively. And then from here, we just left one unknown, which is the c. We can get the answer. And then we substitute back. This is the final answer we need to have. So clearly we can know that from gradient, given a gradient, we can find the equation through integration. So next, another example. So given the velocity, we need to find the acceleration and displacement. So first you need to understand velocity. Velocity is the change of displacement, so therefore it's ds, over the change in time, so therefore it's dt. So for ds dt, we can say it's differentiate of the s, differentiate of displacement. Simply we say rate of change, because rate of change is dt, change of displacement is the ds, so dt ds. As we know the velocity, we can find the acceleration is, we differentiate the v one more time in terms of dt, so we can find the acceleration, so a equal to dv over dt. So it's the rate of change of velocity, or we can say it's the displacement being differentiated twice. I'm sure that some of you don't understand here, you might be confusing. So let's see. So s is the displacement. So after being differentiated, so we got the velocity. So it is called the ds dt. It's the same. It can be v or it can be ds dt because it's differentiated once. So if velocity being differentiated again, so we got acceleration a, or because it said the displacement differentiated twice here. You can see two differentiation, it means differentiated twice. So it's d2s over dt squared. So in order to solve it, so let's say given velocity is 10t minus 5. In order to find the acceleration, we differentiate. Then we got is equal to 10. In order to find the displacement equation, we integrate it. And we got s equal to 5t squared minus 5t plus c. So if given a point, that we can solve the c, and that's the final answer for both. So that's all for today's video. So if not yet follow our Instagram, you can check out Instagram for Geeks SPM. Thank you very much.